Hello, scholars, and welcome to Lesson 4, Session 2. The big topic of this lesson today is going to be this question. What does it mean for figures to be similar? So we're still looking at dilations here, and we're going to throw in a new word for us today. So let's jump right into this first problem here and see what we learn. So this says figure S here in blue is dilated to form figure T. So we started with figure S, that's our pre-image. T is our image. The scale factor here is 1.5. We talked about that in last lesson, scale factor, and we're going to talk about it a lot more here today. And the center of dilation is point A. So everything is expanded out from point A. So here's the question. How are figures S and T the same? Take a moment to think about that. How do you think S and T are the same? Really based on what we've been talking about. So feel free to pause and think, how are they same and how are they different? How are they different? So figure S and T are the same. Here's the big thing. They're still the same shape, aren't they? And what do we mean by that again? We mean that they have the same angle measure. If I took a protractor and measured this angle compared to this angle, I would find that they're exactly the same. This angle and this angle is the same, which means they're still the exact same shape. Well, what else is the same here? Still the same is their orientation. And that's kind of important because this is the only dilation other than a translation that's going to maintain the orientation. It's still facing the same way. It's still upright. It hasn't been turned or flipped over. It's maintained its orientation. Well, what's different then? I hope the first thing that jumps out at you is this is a dilation. So the big thing we're changing here is size. And we're going to remember that this is the measure of the side lengths. So we've changed the size. And, I guess we could say that we've changed position too. I'm not even really that big on that one for this, but we have changed position, right? So here's the big thing. When we're doing a dilation, the shape is still staying the same. We're always going to maintain that shape. We're not going to make something different when we do a transformation. We're also maintaining the orientation here. But dilation is our only transformation this year that's going to change the size. Okay, so a new word, a big word for us. You can box this, you can underline this. I am going to break out the old highlighter here. Figures that are the same shape are similar. Figures that are the same shape are similar. And here's this new word, similar. Now, think about that. The transformations that we were doing last week, all those rigid transformations, we talked about them being congruent. And we said that they had the same shape and size. Well, we could also say that those shapes are similar, right? But we were just being more specific. They also had the same size. But when we do a dilation, we are still going to get a similar figure. So this is an important word for us. We'll definitely see this on our next quiz. Two figures are similar if you can map one figure onto the other by a sequence of one or more transformations. Basically, we can undo this dilation and get T right back on top of S. We know that it still has the same shape. This is how we write that shorthandedly. And notice to do congruent, we had that equal sign with this little tilde. Now we're just doing this little tilde, this little squiggly, that we are going to read as is similar to. So we could say figure S is similar to figure T. Is figure T similar to figure S? Yes. Oops. Yes. It's the same shape. Doesn't matter if it's bigger or smaller. If it's the same shape, it's similar. Okay, this is fun. You might want to pause this and try this on your own. This should be pretty easy. I've got 5 shapes here. They all have 4 shapes here. They all have 5 sides. Which ones are similar? Well, what does it mean to be the same shape? It means the same angle measurements, right? So I hope you see here that A and D have the same angle measurements all the way around. They're the exact same shape, just one's bigger than the other. So we could say this. We could say figure A is similar to figure D. They have the same shape, and that's all you need, right, for something to be similar. Okay, as we switch pages, time for your random fact of the day. Did you know that the first person to get a speeding ticket was driving 8 miles an hour? Yeah, it was in Kentucky in 1896, and he was driving this brand new car, and he was going 8 miles an hour. The speed limit was 2 miles an hour. Sad day for him. Okay, we've got these shapes right here. We're going to call them D, E, F, G, H. Is dilated to form D prime, E prime, F prime, G prime, H prime, I prime. Now, distinguishing between which is your pre-image and which is your image is really important with dilations, because it's going to change your scale factor. It's going to like make it its opposite, right? If you do this backwards, you're going to get 3 as a scale factor, but you're going to be saying that this became this. That's not right. This is our pre-image, the blue one, because it doesn't have the primes on it. And this red one right here is our image. Okay? Okay, so this says it has a scale factor of 1/3. Yeah, it got smaller. Don't you think the scale factor should be less than 1? If it's going to get smaller, basically we're dividing by 3 right here. But we're going to write that as a fraction, so we can always think of scale factor as multiplication. And the center of dilation is x, meaning everything is shooting out from x here. Pshoo, pshoo. Pshoo. Okay, so side D prime E prime corresponds to side DE. Well, that makes sense. This side goes with this side, right? And it just so happens that this is 1/3 of this, right? Because of our scale factor. Now, we can write that as a fraction here by just counting the sides. We counted 1, 2, 3, 4, and put that right here on top of our fraction. Image divided by our pre-image. How long is this? Well, it must be 12, right? Image divided by pre-image. That is what scale factor is, right? Scale factor. It is image divided by pre-image. Okay, so we can calculate the scale factor doing any sides, comparing the image to the pre-image. For instance, E prime, F prime, that looks like it is 1, 2 in length. And please watch carefully how I'm counting here, because some of you need to fix that. Here we go. I'm counting boxes, right? I'm counting lengths. So 1, 2, 3, 4, 5, 6. 2/6. F to G. 1, 2, 3. Compared to 1, 2, 3, 4, 5, 6, 7, 8, 9. G to H. 1. Compared to 1, 2, 3. I to H. 1. Compared to 1, 2, 3. D prime I prime is 1 compared to 3. The question, what is the relationship between the quotients of the corresponding side lengths? They mean quotients, meaning the fractions, meaning the division problems, right? What is the relationship between these? Well, 4/12 is equal to 2/6, so just divide by 2 here, right? These are equivalent fractions. That's equal to 3/9, which is equal to all these 1/3. These are all our scale factor. They all reduce down to 1/3. They're all giving us the same answer no matter what side length we picked here. Well, that's very important. So I can calculate the scale factor doing image divided by pre-image. We just need to make sure image is on top, right? Taking any side length I can find, any piece of information, and dividing it by the corresponding piece of information. Oh, that's going to help us a lot. So how do the measures of the corresponding angles compare? Well, that's like all 90 degrees, right? The angles are unchanged. Unchanged. We should say same shape. Of course it's the same shape. This is a dilation. These are similar figures. Okay, so what is the relationship between the corresponding sides and the corresponding angles in these two figures? I mean, I think we've already answered this. I'm not even going to write anything. The corresponding sides give us our scale factor. They show it's a dilation, and the angles prove that this is still a dilation, a transformation, that these are still similar. They have to be similar figures, meaning that they have the same angles, and they have to give us a scale factor to know that it is a dilation. Okay, so describe 2 ways we know if something's similar. Same shape, same angles, same shape, they're the same shape, and there is scale factor. And what I mean by that is no matter where we measure, we are going to get the same number out. And we might have to reduce our fraction a little bit, but 2/3 is 1/3. Our 2/6 is 1/3. Just divide by 2. 3/9 is 1/3. Just divide by 3. Okay. And you can look at this last one if you want. Obviously, we've got another dilation here. A side length of 3 compares to a side length of 6 all the way around. 3 divided by 6, that gives us our scale factor of 1/2 when we reduce that fraction. Okay? It's just really important that you stay really consistent with where you put these numbers to figure out what your scale factor is. Okay, thank you everyone for your hard work on this, and you should know what to work on next.